So let me start. I'll address the issue of language engineering from a collaborative aspect. As we know, modelers are customers of languages, and they must be closely involved so that they are happy with the languages they are using. Just a few words about me. I'm actually an adjunct professor in Finland, but last 20 years I have been working only in the industry and creating domain-specific languages with various domains, maybe over 100, but maybe just few end-to-end kind of things. So I'm normally acting as a consultant in the early stages of language creation. What kind of thing I have often detected is that the language engineering is something that we know very well in this community over here, is that someone first defines the grammar or meta model, then we define the concrete syntax, and then we define the semantics. And once these are given, then we can provide suitable modeling languages for particular domain, whether it be financial like in the earlier talk, or maybe something else. And while we have these modeling capabilities provided, then the language users can use the models for communication or generating tests, configuration, code, reports, or whatever they prefer. What we have learned is that it is challenging that when people are modeling and they want something new, something special, they want to change the modeling practices, they usually cannot read the meta models or XSD schemas or some other mechanisms to know. So they usually can only comment on the modeling level, how the model should look like, how it should behave, what it should check, what to produce. So what we have tried to do here with a tool called MetaEdit Plus is to enable tight collaboration. So the languages are defined so that a number of experts can define the concrete syntax, the meta model, constraints and generators, and then within the same tool, the language is then provided for the language users. And now the collaborative aspect here is threefold. The first aspect is that multiple people, multiple modelers can edit the same designs at the same time. So not in traditional ID environments that one person programs one file and that's locked, and then you go to the Git and do the migration and merging, but rather that multiple people can edit the models at the same time. And the second aspect of collaboration is also that multiple people can modify and create the languages at the same time. For instance, one person can define the meta model, another person can define the notation, a third person can make a code generator, and so forth. But this talk addresses now the third aspect of collaboration, which is that the people who are using the modeling languages quite often want to update it. They want to have new requirements, or they find out new ways to model, or the domain changes and the language need to be updated. And this process then continues in a collaborative manner. And we have been doing this commercially over 20 years. And what we have learned is that it is very easy to build languages, but it is much harder to keep them running when people are already using them, especially if they have already created specifications so that the existing specifications update while you keep changing the language. Let me demonstrate this collaborative nature of language engineering through a small demonstration. So I'm a Finn, And since we have today minus 10 degrees, we appreciate sauna. And since we like to be high-tech people, we need to have Internet of Things devices to know if our saunas are ready. And obviously, we create a domain-specific language to build these applications for our devices. So what I have here is a small scenario of two persons. What you can see here, hopefully in the screen now, is a person called Jack, who is the modeler. And then we have also another person here called Jill, who is the language engineer. And they are now working in the same language in the same repository of MetaEdit Plus. And I just put the screen colors a little bit different here together with the toolbar comment that you can see who is doing what. So for instance, this is my application for knowing that if my sauna is ready. And I can see here my domain-specific language in a normal manner in the toolbar. And at the same time, also the language engineer, Jill, can also see the same model that Jack is editing. And now let's do some modeling and language engineering at the same time. So Jack goes and adds here accelerator sensor, and the language gives some guidance that the model should be connected somehow to make it complete. And now he adds this kind of capability that if I shake my device, it moves from this ready for sauna state to the measured temperature state. But now Jack is not happy. He would like to log values to the device that what has happened there. But this language currently does not permit it. So he will save it and then say to Jill that, actually, Jill, I would like to have this capability. And Jill can go and see that, okay, you have added this kind of function, but there is no possibilities to say that when you press when you shake the device and the impact is happening, it would be locked that impact to the device. So now Jill will go to change the meta model of the language and can see all the language concepts. And one of these concepts is this one, trigger concept. And she will add it here and change the meta model. And I'm reusing existing value. And he will say that, okay, we will have now this new feature in your language. Go and try it out. And now Jack can go and say, yep, I would like that this impact is now locked. The value is locked to the device that when this happened and what it was. So person modified the language when others are using it at the same time. But obviously now Jack is not happy because he doesn't see in this notation now in the concrete syntax if the log value is changed. So perhaps she asks again from the language engineer to change this. So it could be that Jill goes next to the language definition. And again, I'm a little bit reusing here things just to keep this done in a short period of time. And I would like to add this kind of symbol and show this symbol if the log value is true. So now if Jill can try it out and click this element to see how it works. And then once the Jack accepts his changes, he will see that, okay, and now the log value is over here given, and now it isn't. So what happens, as you saw, everything was happening real time, continuously, no need to migrate, even though we would have multiple people modeling at the same time. So what we have learned from practice is that this kind of approach where the language users can give feedback directly when they are using the language is very valuable and makes the language users much more happier, because normally they cannot comment on the level of meta model specification or other language engineering specification documents. So as you notice, another side effect of this approach is that the effort to create languages and editors is very small. So usually in a couple of hours, you have a first prototype running. Or if you do it completely, then you maybe take a week or two to build it and code generators as well. So the idea here in this collaborative approach is that modeling languages have customers, and we need to satisfy customer needs, especially if you are commercial tool provider like we are. So therefore, the participation of language users is very important in language development, not only in the acceptance in the first place, but more important in the longer run when people want to change the language. And when you are using domain-specific languages, it can be even that you change the language like 3 times a day. That's not impossible. It's even, some of our customers have said that that can be even the pace that they need to change the language. And since we have been working quite long in this area, we have tried to add these kind of collaborative capabilities into our tools. And the effort to create support for domain-specific languages based on industry cases like Panasonic, Porsche, or Polar is normally that it's a couple of weeks effort. So it's not a huge effort, even though in academic literature we find out sometimes that people say that it is very complex and requires a lot of time, but maybe it's because of the tools being applied there. But that's not what we have heard companies to say. Just few words that I have still a little bit time, especially because there's a lot of people here in academia, and our background is also from academia. There is over 100 universities who are using our tool for research and teaching purposes. Obviously, if you are a tool developer guy, then you don't necessarily want to use our tool because you want to build your own tooling. But if you want to build domain-specific languages and try out them for different areas, for example, you write an article with an idea of domain-specific language, and then you want to say that you have implementation for it. With MetaEdit Plus, you can implement it in quite easily, as some of the people here in these testimonials say. So I appreciate for your time, and I hope I was able to show you how languages can be created in a very collaborative, easy manner. And if you have any questions or you would like to see a longer demonstration, feel free to send me an email. And also, if you have any other comments, experiences, or even counter arguments, I'm more than happy to hear about them.